Hey, everybody. Here is our next lesson for, there we go, for today. We're going to talk about another review. Remember, Unit 0 is all review. Our next topic here is forms of linear equations. And this is all stuff we've covered in Algebra 1. The top here says the goal of this lesson is to refresh our understanding of linear equations, also called degree of 1 or first degree from Algebra 1. We have already reviewed linear equations as well as inequalities. I didn't realize I didn't put that on there. I'm sorry. Whoopsie. There we go. Okay, at the top here we have the three main forms of linear equations: slope-intercept form, point-slope form, and standard form. For the first two, it does tell us what's in the form based on the name. And then for the last one, standard form, we've actually already talked about a little bit. Not this year, but in previous years. The word standard is going to be the ones that always are going to use A, B, and C. And you saw that quite a lot in quadratics at the end of Algebra 1 as well. So going back over here to slope-intercept form, I have x, y, obviously because it's a equation that's going to get graphed. And then I have an m and a b. The m is going to be our slope, which is rise over run. And the b is our y-intercept, which is wherever our graph is going to intersect with the y-axis. And then right below here, it says write an equation from given information in each form. And then we're just going to practice writing that equation. So y equals mx plus b, we would just do y equals. And then we'll plug in the m and the b. The m is going to end up being the coefficient of x, which means it's the number that's being multiplied by x. So our m here is 1/2. And then here's our y-intercept. Y-intercept is where x is equal to 0 because it's on the y-axis. And that value is 3. So we would just say plus 3. And that's what it looks like. And then right here below, to continue on with our slope-intercept form, we have two examples here where you can practice graphing them. We'll do this first one together. Actually, we're going to do the second one together, and you can try the first one. It says identify the slope, the y-intercept, and then graph the line. Remember, slope is m, the y-intercept is b. We'll do number 2 first because I think sometimes we struggle when our slope is a whole number instead of a fraction. So number 2 says y equals 3x minus 1. So our m is 3 and our b is -1. So this would look like 0, -1. So that's a point on the line. And we're going to graph that point. And then m is our slope. That is rise over run. If you need to write that down, you can. Here it is right there. And that looks like this. The reason I put it over a 1 is because it's a whole number. And any whole number is technically already being divided by 1. We just don't ever write it down. So I'm going to go ahead and label this is our rise over our run. Our rise is our change in y. And our run is our change in x. So rise is how much we change up and down. And the run is how much we change left and right. And there we go. So let's go ahead and start. We'll begin with b and move with m, if that little phrase helps you. We're going to begin with b at -1. So I'm going to find my y-intercept. It's going to go here on the y-axis. And we know the center is 0, so -1 will be right there. I'm going to put a dot. Our slope is a whole number 3, or 3 over 1. So from my dot, since it's positive 3, I'm going to go up 3. So 1, 2, 3. And I would go over 1. And I'm going to go to the right. The reason I went to the right is because this looks like an increasing line now. So it goes like this. And I know it's going to look like that because this is a positive line. If it was -3, then I could have either done down 3 to look like that, or you could have still gone up 3, but you would have gone to the left 1 to look like that. I'm pretty much always going to stick with, if it's positive, we're going to go up, and if it's negative, we're going to go down. And if you stick with that mentality, you're always going to move to the right to keep it in the right direction. But you can also just always double check and look. Once you fill in your line, I'm going to do it again like that. It should just look like it's increasing if it's positive and decreasing if it's negative. That's also pretty easy to remember. I'm going to do one more dot going the other direction. So starting back here at my y-intercept, Instead of going up to the right, I'm actually going to do the opposite. So I'll go down 3 into the left and see how that puts another dot in the same slope as originally. And then I'll just connect my line like that. If you'd rather, you could also use, let me show you with a highlighter if you want to do that instead, if that would be easier for your brain to see on your paper, because now you're using a pencil. And there we go. Perfect. Hopefully this jogged a memory. Go ahead and pause and try number 1 and then come back when you're ready to check it. Here we go. Go ahead and look at number 1. Here's what you should have. We were only able to fit 2 of our points that are on the line at whole numbers onto the graph. You could have probably squeezed, if you wanted to extend here, you could have squeezed one more like right there. But here are the 2 that fit. We started at 4 at 0, 4, and then our rise over run, or our slope, was -2/3. So I went down 2 and over 3 and put that dot right there. And then I just connected my line. Hopefully this feels familiar from 9th grade. Okay, let's look at our second form. I'm going to zoom in here. So we're at the top here where it says point slope form. This one is called point slope because you need 2 things, a point on the line and a slope. You don't have to have the y-intercept like we did over here. With point slope, it can be any point that's on the line. And then you can see it filled in here. M is the slope, obviously, still. And then x1, y1 is a point on the line. Point on line. You could also phrase it as your given point if you wanted to, because normally it's given to you. There are 2 ways that they will give you questions about point slope form. They will either just straight up give you the point and the slope, or sometimes if they want to make it a little more difficult, they'll give you 2 points and you have to find the slope with the 2 points and then do point slope form. Let's look here where it says write an equation with the given information. Here is point slope form. I'm going to label, this is x1 and y1, and then m is already labeled for you. It's -7. So we would just plug it in like that. So y minus y1 is 2 equals m, so -7, times x minus x1. So x minus our x1 is -4. We're not going to leave it like that, though. Minus a negative is really a positive. Like minus a negative means the same thing as adding. So we would turn that into a plus sign. And there we go. Now let's look at the top of the other page. We have 2 here. It says use the given information to write an equation in point slope form. So we will try number 3, and then you can do number 4. Number 3 says a slope of 1 and 0.00. So it does go through the origin. I'm going to label that slope as m, and then our given point is x1, y1, and then we'll just plug it in. So y minus y1, which is 0, equals m times x minus x1. And then x1 is also 0. This is the correct answer. However, oftentimes they won't just stop here at this form. It's kind of like an intermediate step form. So we would normally simplify this if we can. We don't have to write those zeros down because x minus 0 is just x, y minus 0 is just y. So if you wanted to simplify that, it would just be y equals, and then x minus 0 is actually just x, and 1 times x is just x. So this is actually the simplified form. And that would then technically count as being in slope intercept form because it no longer has like the y minus and the x minus. And that's normally what it's going to be used for, is you're going to be given stuff for point slope, and then you will actually convert point slope into slope intercept form. Okay, see if you can give number 4 a go. So pause and then come back when you're ready to check it. Welcome back. Here we go. So we got y minus 3, or y minus y1, equals m times x minus x1. So 0 times x minus 4. This one I would personally just leave like this. If you wanted to simplify, anything times 0 is 0. So this side would actually turn into 0. So this would kind of be simplified, or it would be easier just to like move the 3 over, and this is like actually in slope-intercept form. SIF, if you will. But I would just leave it like this because you still have the minus, unless it tells you explicitly to change it in a slope-intercept form. Okay, let's go back to the other page and then attack here our last form. This is the one you're going to use the most. Slope form, hello. Standard form is ax plus by equals c. This might feel familiar because the last time you had a lot of equation talk, don't write this down, you were talking a lot about this. This is standard form of a quadratic equation, which is a degree 2 function. We're talking about degree 1s today. It just goes by the exponent here. So here we have ax squared plus bx plus c. That's standard form of a quadratic. Here is standard form of a linear function. And we do have here how to get the slope, the x-intercept, and the y-intercept. Standard form is the easiest form to use to get these, I'll say for sure, unless it's like the y-intercept is just straight given to you like for slope-intercept. But I wouldn't memorize these. I wouldn't worry about trying to remember which one to divide. What you're normally going to do is just from here, solve for y to go in a slope-intercept form so you can graph it. That's normally the easiest way. But we are going to practice putting it in to an equation. So we have standard form here. We're given a is 3, b is 4, and c is 10. So you would just do ax, so 3x, plus by, 4y, equals c. And that's what it looks like. And what we're going to do with it, we're going back to the other page that we were on just a second ago, is we're actually just going to solve it for y and then graph it. So it's kind of the first half is solving for y, and the second half is what we already did over here, practicing graphing by hand. The reason we need to practice this is because in the future, when you are doing stuff with calculators, the formatting of the calculator will not allow you to graph it like this on like the SAT and stuff, or the TSI. You'll have to be able to solve for y to graph it. That's why I want to make sure that you know how to solve for y to be able to graph it so it's not hindering you later on. Here it's identify the slope and the y-intercept and then graph the line. I'm just going to label those M and B. To do this, you will practice solving for y first. Solving for y will result in the equation changing from standard form to slope-intercept forms. Remember, our goal is to get to y equals mx plus b. We will do number 5, and then you can do number 6. Actually, we're going to do 6 together. It's harder. So we'll do 6, you'll do 5. Here's number 6. It says 3x minus 3y equals 3. Whole lot of 3s. First thing you're always going to do is move the x to the other side. X here is a positive 3, so we would subtract it to get it to the other side. This makes a 0 pair because they add up to make 0. I'm going to bring down what I didn't use. And then over on this side, what I'm going to do is actually drop that x term down first, and then I'll put the term that was already there, c, technically, behind it. The reason I'm doing that is because now you see how this looks like mx plus b. If I did it the other way, so it'd be, oops, sorry, that was funky. Okay, 3 minus 3x. If it looked like this, it just doesn't look as much like that, and sometimes people get confused on which one is m and which one is b. So what I think is easier personally is just dropping this term down and then putting this one behind it. If you don't want to do that, you don't have to. You can do the other way. Just make sure you know for sure which one is m, which is attached to x, and which one is b. Now what we'll do is get y by itself. It currently has a coefficient of -3. So I'm going to divide the entire thing by -3. That'll cancel that out. -3x divided by -3. Anything divided by itself is 1. So I'd end up with just 1x or x. And then 3 divided by -3. Again, anything divided by itself is 1, but a positive divided by a negative would be a negative. So it's going to be -1. And here is our slope-intercept form. M is 1 and B is -1. So we would put that on here. I'm going to put a dot at -1 first, where it's going to be on the y-axis. And then the slope is 1. If you need to write that over here, you can. And remember, every whole number is going to be over 1, because anything divided by 1 is itself. So rise over 1 is 1 over 1. So I'm going to start here at -1, a lot of 1s. I'm going to go up 1 over 1 and put a dot. And then I'm just going to keep doing that until we get to the end of the graph. And there we go. Now I'm going to go the other direction. Now, instead of going up to the right, I'll go down to the left, and that will fill in the other side. You can see how it keeps the same slant or the same slope. And then we'll just connect our dots. I'm going to use a highlighter, it's easier to see. And there we go. Okay, go ahead and try the other one. And then come back when you're ready. Here is number 5. First thing we do is move the x over. It was positive, so we subtract it from both sides. And then here, I'm going to zoom in. I dropped down the x term first, so it looks like mx plus b, and then brought the b term down. And then we divided the entire thing by the coefficient of y, which was 2. Remember, this canceled because anything divided by itself is 1, so 1y is the same thing as y. Negative 5 by 2 is negative 5 halves, and 8 by 2 is 4. And that gets us a slope of negative 5 halves and a b, or a y-intercept, of 4. And then on my graph here, I graphed my dot at 4, and then I went down 5 over 2, because it was a negative 5, put another dot. Technically, these are the only 2 dots that fit on the graph, but I didn't want to try to estimate this back half here. So I just counted down 5. I just kind of estimated the 1 extra spot to go over 2. So there's our third dot there for that one. And then connected it with the highlighter. Okay, hopefully this helped and was a good review for you. Thanks so much for filling it out. See you later. Bye.